So good afternoon to everyone. We're just continuing this series that we started last week. And last week I talked a little bit about some context, some concepts, basic concepts as well, some terminology. And today, especially with the live coding example, hopefully we'll get to testing actual React components, so writing an integration test for a page level component. But yeah, before that, I did want to go through like just some really basic stuff. This kind of slide is something that some of you might have seen, I'm sure, many different times before. But it's just the idea of different kinds of testing on what relates to the scope of the test. So you can have something what's called a unit test, right? Which is by its own name, it's testing a unit of code. So something very dedicated like a function or a small component, a small hook, a small reducer, in our case. But then as you start to broaden out the scope of the test, you can have something what's called an integration test. And so instead of trying to test our components, hooks, context providers, Redux stores, instead of trying to test all of that in isolation, we try to test all of those things integrated. So we're going to test to the components that is actually integrated with the custom hooks and the stores, whatever. And then you can try to broaden that even more, something that we'll touch a little bit on next week, which is end-to-end tests. But that effectively is something that ends up being very similar to what the user experiences in production. So you're probably going to end up having a test that touches not just the front end, but also an API. You know, your front end is run on a headless browser, making actual API calls, writing to an actual database and everything. But that's not the topic that we're going to do today. The main thing here is that while a broader test tries to touch on more stuff at once, but because of that, it's more expensive in more than one way. It's slower to write, but also slower to run, so they become more expensive. And a result of this is kind of this classic testing pyramid. So naturally, this pyramid predates even the idea of a dedicated front-end developer, even. But the idea here is that you have a setup where the base, that is most of your tests, are going to be unit tests, covering most of your code, and then you have some integration tests, fewer, and then even fewer end-to-end tests since they're the most expensive, right? But what you might see in the web, and especially in that course that I mentioned last week, testing JavaScript, is something called the testing trophy. And it's mostly the same ideas, but with one main difference, which is you have a much bulkier integration section. And instead of writing most of your tests as a lot of different unit tests, you're going to write fewer tests, but mostly integration. And then you're going to write some unit tests to fill in the gaps. One of the reasons that I can think of in here is just the way, the very nature of front-end development. Something that I did mention last week as well, the user interactions, the way that the DOM works, the way that React and other frameworks deal with state changes and updates, but also the way that we build components of other simpler components. And so things are kind of naturally more coupled, so harder to isolate and really test in isolation. This is not necessarily set in stone. It's not something that you have to follow, but it is something that you will see in articles out there, and it does match my experience. Even before I had heard about the testing trophy, this does match my experience of what's a more practical and effective kind of test in the front end. So just to illustrate this point, so imagine you have kind of an application that has a context provider in its core, dealing with the data, dealing with, for example, Redux-like structure with use reducer, making API calls with fetch, having kind of side effects, stuff for logs, tagging, local storage, whatever. And then you have a component, like a more complex page level components like user form, dealing with the logging form forever, and integrated with the context provider using a custom hook, which is something that you should be doing, by the way. But also making use of smaller components and functions, something like an input button, other kinds of smaller UI-only components. And so the idea is that you could technically isolate all of that and try to test them in isolation as best as you can. It does represent some extra work though, compared to other environments, at least again, in my experience, isolating things in the backend was much easier. So you could try to test the user form in isolation and mock the custom hook. That way you're not integrated to it. And the same thing with the hook, mock the user context and not actually test the results of the user, the hook call. But by doing that, you're not really testing the integration between those units. So the way that the DOM works and deals with events, the way that React deals with state changes again and re-renders your application, and all kinds of business logic that is spread throughout that integration. So the when and the how those functions are being called. All of that is not being tested properly by just unit testing, which is why you do need integration testing. But in our context, this is maybe a little bit more visible. So the idea is that you switch from that approach to an approach where you write, again, fewer tests, but you write integration tests. So instead of testing each unit, you test user form, which is the components, the UI layer, something that your user will interact more directly with. And by doing that, you might end up testing all of the other stuff, right? This is kind of an exaggeration of this process, but the point still stands. So you test user form based on user behavior. That way your hook is already tested as well. And whatever is missing, so you see input in orange here, and that's because, if I'm testing user form, even as a unit test, I'm testing input kind of partially. I'm maybe not testing all of the branches, all the ifs and elses from that components, but I am kind of testing it partially somewhat. And so you use those unit tests to fill in the gaps. Whatever the integration tests are not covering fully, you go in with some unit tests to cover those cases. So kind of an opposite strategy. Again, something that is not set in stone. It's not something that you have to do, but it does match my experience. It is something that you will see Kent from that course mention as well. All right, so a few points on that just to complement that. One is you should be testing based on user behavior and not simply looking at the code itself and how a function works. I'll not get into the whole concept of behavior-driven development. That's something that is its own topic. But the basic principle is that your test will cover user flows and user behaviors and paths. You'll mock and stub as little as possible. So if you have a unit test set up, you're mocking everything around that unit to test that unit in isolation, right? In our case here, we're still mocking something, which is the fetch API. Since we don't actually want to make those API calls, external API calls, that is not interesting for us. It makes the test slower and everything. So, but we will mock some stuff, but not as much as you would in a unit test environment. The whole thing does mean some extra setup work. It's something that I mentioned last week, like the tooling is not as great as something that you will find in some other environments. It is much better, but there's still some things missing. There's still some extra steps that you need to do. There's still some tricks that I've been using for years, even at this point. Once that stuff is inside frameworks and helper libraries, well documented, that problem goes away somewhat. But again, there's still extra steps. And to show that, I do want to share the setup file that I have for event online booking, which is the projects that I work on. So just real quick saying that this file is something that just allows you to run before each test file is run. I just named it jest.setup, but it's something that you add to the config file. But yeah, in here I have a lot of stuff. So you see almost 200 lines of stuff. There is just setup and extra steps, as I mentioned, and tricks. So for example, something for re-rendering after a state change, something that I will show in the example, mocking the global location objects. And some of the tests in there, I did want to test that went through different pages. So I did an action in one page that made the user be sent to a different page. And I wanted to test that second page as well. So I had to do this stuff to be able to use an actual browser router. DOM stuff that is not implemented by JS DOM, like the scroll functions or match media. Global hooks like this one. So for example, we use React Query to manage the API requests. And before each test, I want to clear the cache from React Query. And I don't want to actually call this in each test file. So I just put this in a global hook. So again, extra steps that you might see in other places as well, but in the front end, it feels like there's more work on that setup. Again, hopefully this gets better over time, but yeah. So yeah, just a list of little things that we need to deal with. There's more stuff. I will show some of the other stuff next week as well, like custom serializers and some other stuff. But anyway, okay. So when testing components, compared to the simple test that we did last week, just testing a function, the main things we need to deal with are user interactions and re-rendering, the way that React will take your state changes and then render a new version of the DOM. We'll see that in the example. But I did want to mention just the ways you could make assertions, since we're working now with the DOM, right? We're testing the final results, the stuff that the browser is showing to the user. You could make simple assertions on stuff like, you could still make assertions on function calls, for example, checking that the function was called with the right parameters. That's fine. Making assertions on the location path name, something that I do sometimes in Red booking as well. But most of the time I'm making assertions on the DOM. So one way is to make simple assertions, like maybe you want to check that the button was disabled if the form was invalid or something, or an input value specifically. But we'll see that there is a way to have those checks, especially for integration tests, that is a little bit more efficient. It may be more effective as well, but especially more efficient, which is snapshot testing. So just to recap what the example was, the example application from last week, I have a simple, really simple app where I have the user gets into the page, there's an input, and the user can type some stuff. You get an API request, which gets you a list of appointments. Those appointments get grouped into a single item here because they're all for the same customer, but basically they're grouped by customer, right? So very simple kind of logic. You will see here that I have my customers list and I have only one list item. So I'm going to test basically here for the example, my heavy path. So I already have the test file here. Just going to remove this. And you can see the test description allows user to search for appointments based on name. So you could be testing also error handling cases, loading states, and all other kinds of paths. I'm just going to do this one test so I can show you a few things. But this is not going to cover everything from my component. So I'm testing, again, a page level component. So I'm doing an integration test for that. So the appointments page, which is the component that renders this whole thing. Naturally, it has integrations with the context provider that has a Flux implementation. It has other smaller components integrated as well. So the idea is that with this one test, I'm going to touch on many different parts of my code. So first thing I need to do, I have the steps there at the top. So I need to render my component. So render is actually a function from testing library, which allows you naturally to render a component. And in this case, I want to test my appointments page. And render returns a bunch of different things, including this container objects, upon which I can make stuff like query selector calls. So in this case, I want to just check, and I'll add the data later, but I want to check if customers li. So I want to check that given that I have an API response of 3 appointments, but 2 of them for the same customer, I get 2 list items, right? So I'm going to check basically that I'm showing some results and that those results are being grouped correctly. Very simple kind of test, but we'll see a better way to do this. So to have length 2, naturally I didn't add the data yet. If I run my tests, it will fail, but it will fail with the kind of error that is very common to see as you're setting up the tests, which is stuff about parsing files. In my case here, there's a very simple fix, which is just to mock the module where I import the images. I'm using parser bundler. But if your error comes from, for example, SVG imports, TypeScript stuff, Babel plugins, it's likely that you have to mess with the configs from your projects, most likely from Babel plugins or presets. But I'm mocking this module to say, instead of importing the actual module, this is the result that is going to be there, right? It's mocked. So by running the test again, I don't get the error again, the same error that we had before, but we do have a failing test where nothing's being rendered on the page. So naturally, this node list here has 0 length. So now there's another problem. So let me go to the context. This is where the states for my application is, and I just want to watch the state changes during my tests. However, if I run the test, you see that this console log is not being printed here. And the obvious kind of reason is these tests, being integration tests, need some kind of setup. So usually your app components will have all of these providers, routers, Redux stores, style sheets from style components, custom providers, all kinds of things. And in this case, at the very least, I need this provider. So I need the appointment provider so that it's integrated to that context and the hooks can access the data and everything. You might need some other stuff depending on what kind of test you're writing. And if the setup gets a little bit repetitive, you can also just have a function that creates the context necessary for a component right there, which is something that I did do it in Better Line Booking again. If I run the test again, now I get the states printed to the screen. That's fine. But since I didn't type anything into the input, no requests were made, nothing's being rendered on the screen. So now I need to add some user interaction. The way I do this is by using another library from the testing library umbrella, so to speak, which is user events. And the way I set this up is by saying user equals user events.setup. And I pass this delay equals no. This is just something from version 14. Better Line Booking using version 13 still, so just a little bit of a change between the versions, something that I actually need to look into later. But anyway, so this user objects now will allow me to do stuff like user.type or user.click or double click, triple click, select options, all kinds of different things, ways to interact with interactive DOM elements. So in this case, I just want to type into that input and I want to type the text sem, but to get the input, there's a couple of different ways you could do that. You could just use container.querySelector and just pick the input ID. That's valid technically, but a better way is to look for the actual contents of buttons, of input labels, that kind of thing, because that's what matters for your user. Your user doesn't care about the actual ID. So render will give you all these kind of get functions that allow you to do that. So those query functions, the one that I want here is get by label text, and then I'm gonna get by my label text in there. So if the input is wired to the label correctly, this should return my input. And actually this needs to be awaited. Your test can be async as well, that's fine. So if I run the test, I basically get the same kind of results. Still nothing being rendered to the page. And here's something that is kind of hard to explain with limited time, but I will just mention this. So here's one of the problems. My input, this is the event handler that gets set to the input, the change handler, right? I have here a debounce logic, something that front-end developers are very familiar with. The idea being that I don't want to have a request for each keystroke, so I kind of delay this function from being called for 300 milliseconds. So the problem here is that for the way that the event loop works and JavaScript works, this will not be executed immediately. So I call this, it doesn't mean that at this point fetch appointments has been called, even if this time is 0. This whole thing about the event loop and queuing actions could be its own talk. But the trick that I've learned probably in the Stack Overflow answer years ago was to have something that kind of looks like this. So what I have there is use fake timers. I create a promise and I immediately resolve this promise. And I'm setting up just to use fake timers. The idea being that I don't actually want to wait these 300 milliseconds here. I don't care. I just want to immediately, as that runs, it's almost like it's a set timeout 0, right? And the same is true for other kinds of promises. So the idea is that if I do this, at this point, fetch appointment should have been called because all the set timeout stuff was run already. And so if we run the tests again, we get this error, which is something that is kind of common to see. So this is another thing that is kind of hard to explain with limited time. But the basic idea is that once you're making changes to the state, So in this case, you will see the dispatch function that changes the overall state of the application. You need to wrap those changes inside an act call. Act is a function from React itself, actually. It's exported by other libraries, in this case, testing library. But basically, to be extremely brief, is a way for React to simulate the browser environment a little bit better. We're running this on Node.js with JS DOM after all. So it complains that a state change was not wrapped in Act. Now it should work, but it doesn't. Why? Because my context is calling the actual fetch function. And in Node.js, fetch doesn't really exist until very recently. Even if you do add fetch to this context, installing node fetch or isomorphic fetch, we really don't want to be calling fetch. We really don't want to be making actual API calls. We want to be mocking those API calls, just so that we have an expected environment so we can use for testing. This is another thing that I will be very brief on, but I did copy over a version of what we use again in Line booking. Basically, this is a way to have a set of responses, mocked responses, a function that allows me to mock a response for a given method and URL, and then a global fetch mock, which the main thing is it returns a structure that is kind of similar to what the actual fetch function returns. The OK field, the status field, a JSON function to parse the response into JSON, that kind of thing. So by having this mock request function, I can do stuff like this. So actually, don't need to care about the data too much, other than this is the data that I mentioned before. I have 3 appointments, 2 of them for the same customer. And I'll copy over the rest of the data. Again, don't need to care about that. So now I have a request. So the actual request that is made for this search, so Sam here, Sam in here as well. We return this response here. I have everything connected, everything set up. And if I run my test this time, it should pass, hopefully, and it does. So, and you can see here that the states actually got set to have those 3 results as well. So everything is working correctly. Now, the problem here with this assertion is that it's extremely simple. So the full result of my page has a lot of stuff. So this DOM here that has a lot of content. And I'm only testing one aspect of it, the length of this list here. And even these subcomponents here, the smaller components, can have a lot of different types of logic. And so a more effective way of doing that is what's called snapshot testing. So you do it this way. So as fragment is something from testing library, but to match snapshot is something from Jest. You could match snapshots for anything, strings, object, whatever. Basically, what this is going to do is generate the resulting DOM for my component. So I rendered this, this element tree, and I want to know what's the result in actual HTML for this. So if I run my tests, since there's no snapshot yet, it's going to create it, and I get a new file here. So this is the resulting DOM. It should kind of match what we have in here. So in here, I have all of the result for all of the logic in that page. And so the point is, from this point on, if the snapshot is correct, this is a reference point that I can use if the snapshot changes. For example, if I make a change to one of the components and it changes the snapshot result, the test will fail. And I can rewrite the snapshot if that change was expected. But if it wasn't, it's just a normal test case failing. And I need to check my changes to see what broke that snapshot. But again, a more effective way of doing this. There are issues with snapshot testing, something that we can touch on next week. But this is the main thing about this. And I would say most of the tests that we have in Line booking are snapshot tests, actually. So just real quick, touching on the idea of coverage then, just so that we can see that our single test for appointments page, and you see there is one line, which is the loading state that is not covered. It's already testing, for example, my custom hooks completely. It's already partially testing my context and already partially testing my reducer. Coverage overall is a very useful metric. However, this is not the only thing that you should be looking at to see if your tests are good. Testing quality is not just defined by this code hard number of coverage levels. And very importantly, if you haven't dealt with coverage before, you should know that 100% coverage or even like 95, 98% coverage is something that is kind of unpractical. Firstly, because the simple fact that your function lines and branches being covered, that doesn't mean that they're bug-free. If your implementation is wrong itself, coverages can only give you figures on the code that is there. So for example, my coverage report here is not complaining about the fact that my page, and I'll open the page here, doesn't deal with errors in the API calls. And it's not complaining about that because the code isn't even there. So that kind of thing can happen, but especially coverage, especially extremely high levels of coverage have a big cost. So usually the initial investment of having some coverage, covering some of the paths that your user can take is relatively low, something that is very manageable. But for example, if you want to raise your coverage levels from 95% to 97, you will see that 2% raise needs a lot of effort. And so just generally speaking, coverage is extremely useful, but it's not the only thing that you should be looking at. So quick example for this. Imagine you have an ordinal suffix function. So just a normal function that you can give a number and it gives you the English suffix. So first it gives you ST, 31st it gives you ST as well, but 50th it gives you TH, right? So, and your implementation follows this kind of flow chart. If it ends with 1, ST, if it ends with 2, a different one, 3, a different case, and then the general case is TH. Seems right at first glance, and then you write a test. And for that test, you give a bunch of different inputs trying to cover all the surface area for your function. And for all of those cases, it passes, and it gives you 100% coverage. However, if you give it 11, 12, or 13, it gives you wrong results. So the implementation itself is wrong, and coverage didn't give you any information about that. So again, coverage extremely important, very useful, something that you should be looking at, but not the only metric that is important to assert that your code has good tests, right? All right. I had to be a little quick there, but that's basically it for this week. Next week, I do want to show some of the other tricks that I have, but also touch briefly on end-to-end testing and some other concepts. I'll show very briefly the setup that we have at online booking for the CI, which is where your test should be running as well as locally. But yeah, I don't think we have much time today for questions and that kind of thing. But if you have anything, just go to the JavaScript channel. We have some other people that are also good with testing in the company that can answer your questions. But if you prefer, just send me a message on Discord personally as well. That works as well. But that's it. Thanks everyone for being here, and until next week.